Mathematics may be defined as the economy of counting. There is no problem in the whole of mathematics which cannot be solved by direct counting, said by Ernst Mach. Hello dear students, and welcome to topic 9 and topic 10. This video will cover the combination of topic 9 and topic 10. The learning outcomes that we will cover would be to perform partial differentiation and to apply Lagrange multiplier method to solve maximum and minimum problems involving constraints. What is the differentiation for x? How do we solve this? Fx equals to x. Differentiate x. Answer is 8x. Differentiate y. The answer is the answer is 18y square. This is the first example for solving partial differentiation. Let's move on to another example. Okay, how do you differentiate for x? And how do you differentiate for y? Partial differentiation for x. 2xy will be involved because we have x here, and also x squared will be involved because we have x here. Differentiate 2xy will give you 2y plus 2x. Partial differentiation for y. We will only have 2xy involved in this calculation. The answer would be 2x. Remember that y is a constant here. And x is a constant here. Now let's move on to our second learning outcome, which is to solve Lagrange multiplier method. Find the value for f function x and y equals to 5x squared plus 6y squared minus xy over a constraint of x plus 2y equals to 24. Find the minimum value for function xy equals to 5x squared plus 6y squared minus xy over a constraint of x plus 2y equals to 24 using the steps that I'm going to discuss. First of all, you have to express the constraint in terms of an equation equals to 0 and in the form of g xy equals to 0. How do we do this? The constraint x plus 2y equals to 24 then becomes x plus 2y minus 24 equals to 0. The next step is to form the Lagrange function for x, y, and lambda equals to f x, y plus lambda function for g. It may look complicated, but if you follow the steps, you would get it right. Let's apply this function and get our equation. Let's expand our equation. Lambda multiply with x will give you lambda x. Lambda multiply with 2y will give you 2. Let's expand our equation. Lambda multiply with x will give you lambda x. Lambda multiply with 2y will give you 2 lambda y minus 24 lambda. The next step is to find the partial differentiation for x, y, and lambda. Partial differentiation for x would be 10x minus y plus lambda equals to 0. Partial differentiation for y would be 12y minus x plus 2 lambda equals to 0. Partial differentiation for lambda is x plus 2y minus 24 equals to 0. How do we solve these three simultaneous equations? In order for us to solve it, we have to equate the lambda to obtain the relationship between x and y. To make both the lambdas equal, we have to multiply this function by 2 so that we get 2 lambda. 10x minus 2y plus 2 lambda equals to 0, and we have, this is fx. What about fy? We have 12y minus x plus 2 lambda equals to 0. As could be seen, now the lambdas are equal. Therefore, we can solve this equation using the simultaneous equation technique. 10x minus 2y equals to 12y minus x. We're going to bring all the x to the left and all the y to the right. 10x plus x equals to 12y plus 2y. After multiplying function x with 2, we will obtain 20x minus 2y plus 2 lambda equals to 0. Our function y still remains the same. 12y minus x plus 2 lambda equals to 0. As could be seen, we have the same value for our lambdas. Therefore, we can solve for x and y using the simultaneous equation technique. 20x minus 2y equals to 12y minus x. We are going to bring all the x to the left hand side of the equation, and we are going to bring the y to the right hand side of the equation. 20x plus x equals to 12y plus 2y. 21x equals to 14y. Y equals to 21 over 14x, whereby y equals to 3 over 2x. Now you have to replace this into the third equation, which is x plus 2y minus 24 equals to 0, in order to solve for y. Now you have to incorporate y equals to 3 over 2x into this equation in order to solve for x. X plus 2y minus 24 equals to 0, and as we know, y equals to 3 over 2x, which will be replaced here. X plus 2, 3 over 2x minus 24 equals to 0. X plus 3x minus 24 equals to 0. 4x minus 24 equals to 0. 4x equals to 0 plus 24. 4x equals to 24. X equals to 24 divided by 4, which is also 6. If x is 6, what is y? Replace it back. Y equals to 3 over 2x, 18 over 2, and y is 9. Therefore, the final answer is x equals to 6 and y equals to 9. In order for us to minimize the function, let's replace x and y into the main function in order for us to find the minimum value. The main function here is fxy equals to 5x squared plus 6y squared minus xy. X is 6 and y is 9. This is how we solve the equation. Therefore, the minimum value is 612. I hope you could apply the Lagrange multiplier method to solve problems involving constraints. Thank you very much. Have a nice day.